State what is meant by damping, right? Damping is when you have like a dissipative force, right? So put that in your own words. What are we? What are we? What do we mean by that, right? Okay. And then here, calculate the Q factor, right? Okay. Again, this is you're going to read off this value here and that value there. What's interesting to me is in the mark scheme they give this value. It's very strange what they say for that value. Just when you look at the mark scheme, just you'll have to give me your opinion. Okay. So I feel like I can read that. Okay. And you're going to do this. This is that same calculation. 2 pi x, I'll call it x1 squared over x1 squared minus x2 squared, where these are the amplitudes of the first peak, x1, and this is x2, right? And this comes from the formula Q is 2 pi energy stored over energy dissipated, right? So the dissipated is, and yeah, anyway, yeah, okay. The Q factor of the system increases. State and explain the change to the graph. Okay, so decide what increases means. Remember, Q factor is roughly how many times it oscillates. Okay, so they're saying that it oscillates more times, right? Okay, so what's that going to do to the shape of this graph? Okay, talk about whether does it die off faster or does it die off more slowly? Okay. And then explain why that is. Okay, so I think what you want to do is say, if it increases, what happens to the damping force? Does it get more or less? And then that's why the graph does what it does. Those are the 2 marks.